All right, so we're starting a new unit. It's called sequences. Okay, this unit seems a little weird and does some weird formula stuff. It's really important for next year because you're going to be doing like the harder versions of these ones. But basically what we're doing is patterns. Okay, and with our patterns, we're trying to come up with a way to express patterns in a way that is uniform and the same for everyone. So when we look at these three boxes, all of you can see the pattern. You know what's coming next. If I drew the next thing in the pattern, it would be 4 boxes, right? Okay, let's say they were like the same size. So that's clearly the pattern, but we need a way to be able to express this and use words to talk about it. So when we're talking about patterns in math, we always want to boil it down to numbers. So if I look at these, let's say it's number of lines, right? So this would be 4, 7 lines, 11, and then what's this, 15? Not 15. What's wrong with me? 10, 13. Okay, that's how many lines are in these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so that's how many lines are in each of the pictures. These numbers are happening in a pattern, and this pattern, this list of numbers that create a pattern, is called a sequence. Okay, a list of numbers is a pattern. It's not weird. Terms is what we call each of these numbers that are in the list. Okay, so that's a term within this entire sequence. Now, in math, when we talk about first term or second term, we use these symbols. So the T represents term, and whatever number is beside it, the little number here, represents not cubed. Cubed goes up here, right? That just means third in the list. And so if I was going to say T3 in this sequence would be 10. Okay? That's just some math words, and in the questions you're going to do are going to use stuff like this. So there's 2 types of patterns we're going to deal with, 2 types of sequences. Let's look at this one right here. Okay, so it goes 2, 5, 8, 11, 14. Every time we're just adding 3, adding 3, adding 3. This is called an arithmetic sequence. Okay, that's when you're adding numbers. The other thing is you can actually have negative arithmetic sequence. So let's say you had you started at 2, but then you subtracted 3 every time. It would be -1, then -4, then -7, etc., etc. So that's still arithmetic, even though it's negative. The other type is multiplying every time. So let's say we started with 2 and we do times 3, then times 3, then times 3, then times 3. That would be a geometric sequence. We're not really going to do these this year because they're super complicated. You are going to do it next year. You need to be aware that they exist and be able to work with them a little bit. You can also, again, do negatives. So let's say our geometric sequence was times -2. So we start with 2, the next number would be -4. Then the next number would be +8. Then the next number would be -16, etc. Because they're multiplying by -2 every single time. So there's also finite and infinite sequences. So infinite, most people know, infinite means forever, right? Goes on for infinity. So when we have a list of numbers, the sequence right here, the terms, when we have the triple dot at the end, it means that it is continuing forever, for infinity. If you don't have the triple dot at the end, that means that it's finite, which means limited. Those are the only terms. There is no term after this. Okay, some situations this makes sense, some situations this makes sense. We are going to express these as functions, which remember just means an expression, an equation, right? So like y equals or f at x equals whatever. So let's look at this situation and try and make the actual equation. So we need to set up these. So we said this was 4, this was 7, this was 10. We also need to have these are the terms. Okay, that is going to be y or f at x. F at x is always the output or the term numbers in the list. We also need to have x, which is basically, the way I like to think of it is the figure number. This is the first picture, the second picture, the third picture. The reason this is going to mess a lot of people up is because when we did this previously, we always started with x is equal to 0 in our table of values. There is no 0 with figure. Okay, that doesn't make sense. You don't start with 0, you start with 1. So that is the big change and weird thing for your graphs. We don't have a 0. Okay, we start at 1. When you do your graphs, there still is 0, so you would start like at 1 here. That would be your first point, whatever. So as you can see, it makes a pretty clear table of values. So let's write our equation. So our equation could be f at x is equal to, or y equals, same idea, something x, whatever the change is. So in this case, every time our output is increasing by 3, that means that our slope is going to be 3. The plus is whatever we start with, and this is where it gets kind of tricky. We're not actually going to put 4. We're going to put whatever would come at 0 if we were writing the equation. So in this case, it's going to be plus 1, okay, or 3x plus 1. This is just a basic idea. You need to be able to graph this so you can understand it, which is what we did last year, just to show you that we can turn these into equations. We're going to spend a lot more time on this in next classes. The big idea for you this class is to understand those definitions. And that's it.